Unfortunately, I couldn't be there physically, but I'm very happy to join virtually. And today I'm going to be presenting a different paper than the one that was cited earlier, where we show that LLMs appraise emotions as accurately as humans or better. And this is work that I did with Noah Oded, this was part of her honors thesis in her lab, and she's now in Tel Aviv University. Shir Genzel, who is now finishing her PhD at our lab, and of course my advisor, Anat Perry. So to start, I want to introduce you to Sarah. Sarah shares with you that her partner just decided to leave her out of the blue, and she doesn't understand how this could happen. She really thought that they were solid, especially that they did so much work on the relationship last year. And if you had to, I want you to take a moment and think how you could know what Sarah is feeling if you were having a conversation with her. In other words, what we're actually asking is what information matters for cognitive empathy and for a correct appraisal of a person's emotions. Intuitively, we might think that visual information that includes facial expressions matters a great deal and would allow us to accurately understand what the other person is feeling. However, past research did show that visual information does not increase empathic accuracy compared to auditory information. But auditory information includes both paralinguistic information and the semantic content that the person actually said. And this distinction between these two features has been less explored. Coincidentally with this, LLMs could potentially appraise emotions from text due to the fact that they are specifically trained to mimic language comprehension. So an LLM could take what Sarah was saying and accurately detect the emotions in the text purely using the text. However, the fact that an LLM can't genuinely share any sort of emotions and can't actually feel any sort of reaction may interfere with this, unlike a human. And the LLM, of course, does not have access to the prosody, intonation, speaking rate, etc. So we wanted to know how well can LLMs appraise emotions. Now, this is not to say that LLMs can actually understand, in the deep sense of the word, what one's emotions are or what it is like to experience them, because again, there is no feeling entity on the other side, but they may be able to accurately appraise emotions, and that could be a useful tool, and that is what we set to examine here. Now, there's a huge literature in affective computing about developing algorithms for emotion recognition, but a lot of it uses data that is either categorical in the sense of, is this emotion there or not? Binary and whether it is, categorical in the sense of which emotion is this? You could be angry or disgusted or fearful, but you can't be all three. Binary, is this emotion present? Not. Some of them use very heavily annotated data sets that usually are not ecological, and that most importantly are freely available online, and the correct answer could just be part of the model's training data. So we wanted to answer this using very secure naturalistic stimuli, and to address this question, we designed the following study where we took ecological videos of people sharing personal stories. These stories are in Hebrew, that were previously shared by storytellers in our lab. For legal reasons, this data set is not up online and is not freely available, so it couldn't have been part of the training data. And we then had transcripts for each of these videos. And we had three groups. The first was a group of human participants who watch the full audiovisual stimuli. The second is a group who read the transcript. And the third is a group of different AI models, each with 60 iterations. And all three of these types of raters, after they were exposed to the stimuli, were asked to rate the intensity with which they believe the storyteller felt 8 different emotions, 5 negative, 3 positive, and 8 in total. And we did this for 12 different stories from 10 different storytellers. And because we have the storyteller's original ratings, we can then compare the ratings that these raters gave us to the original ratings and see how accurate they were. So what did we find? Here on the y-axis, we have the calculated empathic accuracy score, so how accurate they were. And on the x-axis, we have 3 different LLMs and the human raters in the text conditions and the human raters in the full audio-visual conditions. And to start, we see that humans in the audio-visual condition do perform better and more accurately than humans in the text condition. This is not very surprising because we know that the audio information at least does matter. So that could be what's doing the work here. However, even just relying on the transcript, we see that LLMs can be more accurate. And this is true not just for GPT, but also for Claude and Gemini as well. Even when we split this finding for emotions of different valence, we see that some models were better than the human raters for negative emotions, whereas other models were better than the human raters on positive emotions. However, in no case were they significantly worse than the human participants. That said, we did observe that LLMs generated a lot of identical responses. It was very, very rare for 2 different human participants to provide exactly the same set of 8 ratings. Whereas for LLMs, this was relatively common. It changed a bit between them, but it was relatively common. And this raised a technical concern about the variance differences between the groups. So to battle this, we took the transcripts and we generated a population of AI ratings. We ran each story 10,000 times, getting a total of 120,000 ratings. And as we did before, after each story, we asked it to rate the different emotions. And this allowed us to create a population of AI ratings and just refer to the mean of that population. So we took this Gemini population, and here on the y-axis, again, is the appraisal accuracy. And on the x-axis are now only the human raters, because we are comparing them to the mean of the population. And we see that in both of these conditions, the average accuracy is still much lower than the mean of that population. And we tried this both when looking at the people as individuals and both at the different observations and comparing to the mean of the population or to the mode of the population. And we still find that the model outperforms the human raters. So what does all of this mean? First, it suggests that the semantic information does contain the relevant emotional information for accurate emotional appraisal. However, given that the human participants did perform better with the full stimuli, that suggests that to best process and best appraise other people's emotions, humans do need the full audiovisual information. So humans still benefit from the richer stimuli, even if LLMs can extract more substantial information. Now, this ability of these AI models could be useful. It means that we can build AI tools to aid in introspection, to bridge and help in communication and in interpreting others, and could also serve to improve human communication. So if we go back to Sarah's example, it could help her understand both what she and other people are feeling in the situation. However, this could also be harmful. This could lead to potentially unsolicited tracking of emotions just from taking a text that someone wrote and tracking their emotions. But even when used with the best of intentions, this could fundamentally change human relationships. Human relationships grow as a result of having some rupture and repair, and using AI tools to constantly interpret others, understand them, removes the potential improvement that follows these misunderstandings, removes the potential for investing effort in the relationships. And more important, and moreover, we also know from our previous research that accuracy is just not enough. These things, this effort and this attempt to bridge over gaps and this emotional engagement is the thing that people value about human responses and human engagement. So this accuracy might not be enough. And also, lastly, this may not apply to minorities or clinical populations, which is probably where we would want to use this most. There is some, for example, there is some talk in the literature currently about using AI as a tool to bridge between autistic people and neurotypical people, which might not be very helpful for helping neurotypical people understand autistic people if the LLMs are trained mostly on neurotypical data. So to conclude, we know that LLMs match or outperform humans' emotional appraisal abilities. And while this does show the depth of information in the linguistic patterns that express emotions, and could potentially be used to help us interpret emotions better, it could also have some harmful consequences and mainly not work for everyone and not provide the correct emotional engagement. Even in the best cases, this ability is useful, but it is not enough to replace full human communication and empathy. I'm open to any questions and ideas, and I'm happy to chat about it more. There's a QR to the paper, which came out about a month and a half ago. And yeah, I'm very happy to chat more, or you can find me either on LinkedIn or at this email address.
Time for one question. Okay, go ahead.
So wonderful, and it's cool, and there are lots of good uses, I think. One question, just we've done a similar thing with looking at our students at Wharton giving presentations, looking at audio, video, and text. And we find is that for warmth, the audio has more signal, whereas for competence, the text has more signal. The morality I won't talk about. So my question is, you've got everything set up. It seems you should run the audio through through a modern LLM as well. We're getting lots of signal out of the audio. We're finding the video technology is not quite there yet, but this seems like a great next paper for you. So suggestion is, you've got it. You've got the three modalities. Look at in them separately.
That would be super interesting. I will say, though, that part of we had some initial problems with why we didn't do it, but we also see that just given the transcript, and also a reminder that the transcripts are already in Hebrew, which is a language that the models are not trained on because it has very little representation in online data. So even using those limitations, we see that such a ceiling effect. We see the models score at around 90% out of 100. So what you're saying could possibly improve it, but there's also very little room for improvement anymore. And these are also models that were state of the art at the time, but are also somewhat outdated right now. So I think it will, even from the transcript, it already gets enough information. So I think that's definitely an interesting thing to think about and to potentially try and parse out the information in a better way than we have right now. But in terms of building tools for accurate emotional appraisal, this is already pretty much enough.
Thanks, Matan. Great talk. I wanted to follow up about that 10%. It's not getting right. What characterizes that 10%? And is that 10% dramatic? Do humans get that 10% correct? Or are both humans and LLMs getting that 10% wrong?
So to explain this, I will explain a little bit more about how it's calculated. We had 8 different emotions, and we see that the LLMs do tend to rate 1 to 2 emotions very intensely, and the rest pretty low, not all ones, but pretty low. Whereas humans tend to try and look for a little bit more nuance and like more emotions that are on the middle scale. This is not something that we've looked into systematically, but we totally could. And that's a very interesting idea if it's the same 10% or not. But my educated guess from looking at the data would be that it's this slight overestimation of specific emotions that tends to happen more in humans than in the AI, leading to a greater error rate.
Thanks. It's super interesting. I don't want to be the non-empirical researcher who's like, I don't find your results surprising. But there's a certain sense in which I don't find them surprising, because there's like these things are trained on such a large corpus of information that the snippets that you have seem like they would be relatively easily mapped onto parallels where there's also going to be in more of the text more overt like emotional markers. So what I would actually be curious to know would be, how simple of a model can you actually replicate your results with? Because I would think that you wouldn't need the full frontier model. You could have fewer parameters, and in fact, you could probably train, if you had the right corpus, you could probably train one up, sort of specifically, and see how much you could recover. Another thing that I would really like to know too would be if you took the exact text that you have and you changed some of the words so that, instead of it being like, oh, I broke up with my boyfriend this weekend and blah, 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 which is going to map onto lots and lots of very, very similar strings. But if you just permute the words, right, I broke up with my, ant farm this weekend, or, like something really, whack far, like how far, how much do you have to permute to see these things drop? Because this, in a certain sense, then you could tell how much of it is those words are mapping you into a certain part of the parameter space versus how much of it is the rest of the construction, if that makes any sense.
Yeah, so I'll start with your second question because it's a little bit easier for me. This is something that I've thought about a lot, and it could do more than show me where we are in the parameter space. It could show us which information in the semantic representation matters for accurate emotional appraisal. Which are the words that if I take them out, the model performance does worse than humans? Where is the advantage? So that is something that we are currently thinking about. In regards to the point about the corpus, part of what I really like about this project is that it's true that these LLMs have a huge corpora that they're trained on, but not a lot of it should be labeled with the specific intensity of specific emotions, rated from 0 to 8. And a lot of the algorithms, there are a lot simpler models that can appraise emotions with some accuracy. But if you look at their training data, a lot of it is either based on basic emotion theory, which is a little bit contentious, or based on annotated data that is usually that, for example, a lot of data sets use audio snippets that are recorded by actors where the expressed emotion is unrelated to the content of the sentence. So this model is not trained for emotion recognition, and it could be making up for it with a lot of parameters, but it already does an excellent job at which is comparable to those simpler models without being based on a corpus that is that has had choices specifically about emotions made in its construction, which could bias it into specific ways.
Excellent. Thank you very much, Matan.
All right. Thank you all for listening.